This video we're going to look at solving compound inequalities. Compound inequalities means that there are two parts to it, and there's two different versions. You can have an AND, which means that every solution has to work in both of the two inequalities. So only numbers that meet both requirements. So for instance, if we look at this, we need numbers that are greater than or equal to -1, and they also have to be less than 2. So we could use -1, we could use 0, we can use +1, we can use +1/2. So any number that's more than greater than or equal to -1, but also stops at 2 will work. So we're going to graph these the same way, and these two things say the same thing. This is an AND, this is also an AND when it's kind of sandwiched in between. So it's like having the meat on your sandwich. We need it to be sandwiched in between a little bit. Alright, so when we go down to our number line down here, we need open circles for the one on the right, and a closed circle for the one on the left. So there's actually nothing to solve on here. This one's just a graphing. So when we go to graph it, we need to have our -1 is down here on the left, and our 2 is up here on the right. And you might check with your teachers. Some teachers are going to want you to number everything, so 0 and 1. Some teachers won't. Right? But greater than or equal to -1 means we put a closed circle here, and it's going to go this way, and an open circle at 2, and you can see that's the stuff less than, that's all the stuff in between those two endpoints. So those are going to be your solutions. So any number that's in there, excluding the +2, because 2 is on the open circle, any number that's in that shaded region will work. Right, the other ones are what are called OR questions. And OR questions means as long as any number that works for either one or the other, could work for both, but it has to work in either one or the other. And I picture this as you're putting oars out in the water. They tend to point outwards, not always, but sometimes. There's no shortcut to writing it. You always have to write it so that you have one that has your actual answer in there with an or in between. So again, if we put our numbers, we have 1, 2, 3, and 4. So we need a closed circle here at +1, because it's or equal to, and that's being shaded this way, and greater than 4, so shaded this way. So an open circle shaded to the right. So the only numbers that wouldn't work in there would be 2 and 3 if you're looking at whole numbers and any of the fractions in between there. So as long as the number is either less than 1 or greater than 4, it will work. Now sometimes we have to solve these first. So on these two, we're going to solve these, and I'm actually going to do number 1 and then I'm going to do the two ands together. All right, so here we have 3 different parts. So it's a regular inequality, only there's 3 pieces to it. So there's a piece over here on the left, there's one in the middle, and then there's one on the right. So normally when we solve an inequality, we work with just 2 pieces. We're going to have to work with 3, so we still want to get that x by itself right here in the middle. So to get that x in the middle, we have to get rid of the 7. All right, so we kind of going to put a box around what I need by itself. So I need that alone. So to get rid of the 7, I subtract it. So I'm going to subtract it here. But since there's 3 parts to this inequality, I have to subtract it 3 times. All right, so -73 minus 7 makes -80. Those 7's cancel out. I'm going to bring the less than symbol down. I'm going to put the 10x in the middle. And over here, I bring the less than down again, and I have -10. All right, now to solve this, I'm going to divide. I need just x, so I have to divide by 10. And instead of dividing just 2 things, I'm going to divide all 3. So I have -8 less than x less than -1. So it's sandwiched in here in the middle, so that's an and. So we need the overlapping stuff. So our -8 is here, our -1 is here. So we're going to put our open circles, and this part right here, we think about -8 is less than x. What that really means is x is greater than -8. So that's the stuff over here, sandwiched in between. And the -1, we want all the stuff less than. All right, so this is really saying this piece, which is why we shaded to the right. Okay, now I'm going to hop over here and do this other example here because again I have an and where I have 3 pieces. So here's the variable that I want to isolate. So I need to get rid of this minus 5. So I'm going to add 5. And I'm going to add it to all 3 parts. So negative 8 plus 5 is negative 3. Bring down my less than. I have a negative 3x in the middle, less than or equal to 9. All right, now to get my x by itself, I have to divide by negative 3. If you remember from our rules for dividing by negative, we have to reverse that inequality sign. So we have 1, and instead of doing this less than, we're going to flip it around and make it a greater than. Right? We have just x in the middle, but we're going to do the same thing here because we divided by a negative 3. So we're going to flip it around and make it a greater than or equal to negative 3. All right? So when we look at this, we usually want our smaller number to be on the left. So I'm going to bring the negative 3 down here, the x there, and the 1, and then I'm going to turn these back around. All right? So this part here is showing me that x is greater than or equal to negative 3. So I need a negative 3 on my number line and a 1. This one gets a greater, or a solid circle, closed circle. And this one gets an open circle. So again, I'm using all of the things in between. For our OR questions, these are just done as 2 separate inequalities. So we just solved the one on the left, and solved the one on the right, and then we put them both together as one solution. So we do minus 2's here. So 5n is greater than or equal to 15. Divide by 5. Gives us an n is greater than 3. Then we move over here to the one on the right. And we have negative 7 is greater than 0. We divide by our negative 7, which means we have to flip that around. Now, we do have to have one place where we write our whole entire answer together. We have to have that word or in on all the or questions. All right, so our 0 is our smallest one. And we're going to put a solid or a closed circle here at the 3. The stuff that's greater than goes this way. An open circle at 0. So there are our ors out in the water. So the ands, remember, are sandwiched in between the 2 endpoints. Ors, we put our ors out in the water. All right, so if we do this very last one here, again, we're going to solve. So we're going to add on 1. So negative 4x is less than or equal to negative 16. Divide by negative 4. We divided by negative, so we have to flip our inequality around to being greater. And then we're going to move over here to the one on the right. Subtract our 9. So negative 6x is greater than 3. And we're going to divide by negative 6. So x is, we divided by negative, so we have to flip it around. And 3 over negative 6 is really negative 1/2. All right, so our answer, we have to have one spot where we have the or with both inequalities. So our negative 2, negative 1, 1, 2, 3, 4. Oops. So we have an open circle at negative 1/2, which is in the middle, shaded down to the left, and a closed circle at 4, shaded to the right. So those are our ors. Ors in the water. Right? And or sandwiching in between, ors are ors in the water.